All right, welcome to our third part on the National Electrical Code and Photovoltaic Systems. This is the course from Mayfield Renewables. In the previous two parts, we went into the beginning parts of code and then went through Article 690. In this one, we're going to continue in with code. We're going to start with Article 691, and then we'll spend the bulk of our time in Article 705. So let's first look at 705.12a1, and so we're in feeders and taps at this point. So feeders and taps are when we are going to make a connection to a feeder. So in this case, we're not making a connection on a bus bar. We are not going into that main service panel. We're not going into that distribution subpanel. So somewhere along the way, you want to tap onto these feeders. And this is a pretty common thing, and there's a whole section in 240.21 talks about doing this for loads, but in our case, we're actually providing another power source, and so we need to be cognizant of that, and we need to be making sure that our conductors are sized properly, because now we're adding amperage to these conductors. Potentially we're adding amperage to these conductors, and we need to make sure the conductors are sized properly, we have the right overcurrent protection and things like that. Ground fault protection for our systems, if we have ground fault protection on that main breaker in this case, what this is the general rule is saying, if there's ground fault equipment where it's required by elsewhere in the code, then our interconnected system, our PV system, our power production system needs to be located on the supply side of that ground fault protection equipment. Of course, there's the exception that if the manufacturer says it's okay that you're not going to damage, or the ground fault protection device will still operate properly even when there's a power source on the load side of it, then you can go ahead and put it on the load side, the 705.12 application. This is getting more and more the case. We are seeing this all the time. We're talking to manufacturers, getting that approval. So if you are doing, this is going to show up in large commercial and industrial projects, 1,000 amp system, 1,000 amp services. You'll just want to talk to the manufacturer, make sure this is a step that you'll want to go through, check that box, make sure so that you are installing this properly. What we have here in this image is we're showing exactly that scenario I talked about earlier, where we have multiple circuits that are feeding the different panel boards or the different inverters, which we can do. If you go through and you do this, then the thing to note is those individual circuits get treated in that C1 through C6 separately. It's not you take the worst case scenario. So for example, if that top panel board if the overcurrent device, that fuse disconnect in this case, was 10 feet or less from the transformer on that top section, then that you would follow that rule for 240.21c. If the bottom section was 20 feet away, then that you would apply this section, the C6 section, in order to properly apply this. So you apply them separately. You don't take the worst case scenario and apply it to all of the circuits on the secondary side. So let's look at the main part, or the heart of this section, I would say. So secondary conductors, when we are putting overcurrent protection on them, this is going to say we're going to read through this rule. The secondary conductors shall have an ampacity of at least this amount. We are going to then take that value, compare it to the overcurrent protection that we calculated back in 450.3, and we may end up having to put in larger conductors because of that rule that says we have to have conductors that are sized to the size at least as large as the overcurrent protection. This is just telling us what the bare minimum size is. So we're going to take those, we're going to compare them, and we'll ultimately, in most cases, be looking at this and saying, well, this is saying what our minimum size is, but my overcurrent protection is larger than that, so I'm going to size my conductors to the overcurrent protection. I'm going to show you a little math here to kind of walk you through this and illustrate what that means.